A project title is Continuous User Identity Verification Based Secure Internet Services, done by D. Hemalata, S. Madhuri, A. Vijayalakshmi, guided by Mr. M. Ramesh Kumar, Assistant Professor of Department of CSE Multitech. Our project is due to improve the secure internet services with some improved technologies. The session management in the distributed internet service is traditionally based on username and passwords. And due to the emergence in the biometric solutions allows the substituting username and password with the biometric data. The length of the session timeout may impact on the usability of the service and consequent client satisfaction. A secure protocol is defined for the perpetual authentication through continuous user verification. Existing system gives that the security of the web-based application is a serious concern due to recent increase in the frequency and complexity of cyber attacks. The biometric techniques offer emerging solution for secure and trusted authentication where username and passwords are replaced by biometric data. And we found the disadvantage of this existing system is, however, parallel to the spreading usage of biometric systems, the incentive is there. Misuse is also growing, especially financial and banking sector application. The services where users are authenticated can be easily misused. The proposed system gives that the proposed system performs user verification process in a continuous manner rather than one-time occurrence. The use of biometric authentication allows credentials to be acquired transparently, that is, without explicitly notifying user interactions, that is essential to guarantee their service usability. The advantage of the proposed system gives that the CASHMA is able to operate securely with any kind of web service, including services with high security demands as online banking services. The proposed system is intended to use from different client devices, example smartphones and many Android devices and desktop PCs that needs the special processor which consists of the Snapdragon. The literature survey gives some of the surveys we have done with some papers, and from this paper we got the disadvantage of the security analysis tool using the advice method is currently under development. And the next paper, this we found the disadvantage that the biometric verification is the main bottleneck in the computation, and we are looking as to how to offload them into FPGA based. The next paper, we found the disadvantage that the proposed system quantifies the biometric systems without taking into account the environmental and the operational conditions of the biometric systems. In this paper, we found that the different scanners detect different types of vulnerabilities, but a single tool is not capable of detecting all types of vulnerabilities. The next paper, the limitation of the current state of the biometric technology should not be constructed to imply that it is not currently useful in many applications. The next paper, we found that the goal is to help our system designer to get a clear picture of the attacker mindset and stay focused on it during the system design, which is very much important in the security. And in this paper, we found out that the logs are not able to provide information about the failures due to software faults. In this paper, we found out that since the stronger modality is typically selected for the verification, it is also offers the reduction in the computational time. In this paper, we found out that this property would not be true if the server can be disabled using the denial of the service attack, and this is universally quantified. This paper, associated with the threat agents, is conclusion and coercion, where the legitimate users are pressurized in some way to provide their biometrics. From this paper, we got the idea that the challenge comes from both the inherent complexity of such systems and needed to represent many different aspects of the system behavior. In this paper, we got that the gathering a true multi-modal database is very important for the continued work in this field. The architecture diagram says that when the request is sent from the client to the web service and to the CASHMA authentication service, the computational server does the comparison purpose with the authentication server and the database which is stored, and with this the web service is proceeded with the process, or else if in case of any misuse the session is terminated with the web service. And next comes the example where we implement the CASHMA app with the real-time online banking app, where the comparison and all those done with the CASHMA app and the CASHMA authentication service, and the online banking app will be running in the background, which shows as an example for this project. That is the secure internet service. The sequence diagram gives that the procedures which is done in the sequence manner. First, the login is done with the client, and the banking service gives the acknowledgement back to the client, and where the authentication service is done then and then with the checking the biometric data, and it is continuous process which has been done while the thing is done, and the background is done with the net banking and balance checking, etc. The use case diagram includes the actors, the client and the CASHMA, and all those are the same works which are done in the sequence diagrams. The activity diagram states that between the client and the CASHMA, where the biometric data are continuously given and is compared and passed over to the database and the authentication server. With this, the checking is done and the comparison work is done, whether if it is an authorized user, it is proceeded with the banking service, or else it is unauthorized server user, so it is session terminated. The data flow diagrams gives the flow between the client and the banking service with the CASHMA app. And the data flow diagram level 1 consists of the CASHMA level with the client, which consists of the authentication server and the database, and the next level comes with the banking service, where in the next data flow level 2 we are going to develop the banking service into somewhat elaborated manner, so the net banking, user profile and balance has been included. And the minimum hardware requirements which is required here is the processor Snapdragon, memory 8 GB, RAM 1 GB. Software requirements: the operating system which has Android 4.1 plus, coding language is Java being used, front end is Eclipse, hosting server Apache server. Modules: it consists of 5 in the CASHMA authentication service, web service, client service, biometric templates, CASHMA certificates. The web service states that these services are potentially any kind of internet service or application with requirements on user authenticity. They have to be registered to the CASHMA authentication service, expressing also their trust threshold, which is done with only the logins and the password, which is initially created for the new user and it is stored in the database. Client service: this gives with the client means the user devices and all those being included in this. The client contains the sensors to acquire the raw data. The CASHMA application which transmits the biometric data to the authentication server. All the user devices and the profile is being maintained in this client server. Biometric template: the CASHMA authentication server exploits data from the client devices to apply user authentication and successive verification procedures that compares the raw data with the database. CASHMA certificate: it is the final certificate given after the comparison, so the timestamp and the sequence number invocally identify each certificate and protect from the reply attacks. This is the final product which has been given to proceed with the web service, that is proceeding with the background work such as net banking, etc. These are the screenshots, which is a welcome page, and the new register has to use with this form, which has to be filled with the full name, email, password, mobile, and then the user has to register with them, which has been proceeding with the net banking. The send to is just the account number where the transaction is done, and the amount is just the balance. This is initially where the user has to give their user profile, password and login, and where the verification is done at the background with the stored database with the user profile and all those, and proceeds with the web service, net banking in the background. Here the image is being confirmed with the person, where the photo or the image of a person is being given from the front camera of the mobile, and the position is being fixed and the faces are being detected and identified by the front cam and being stored in the database. And here is continued with the banking, where user profile, net banking and balance is being shown. Once the user can also check with the user profile, where the name, username, account number and the mobile number is being provided. This comes the balance checking, and which is the final product of the project. The conclusion is just at present our prototype only performs some checks on the face recognition, where only one face is considered for identity verification and others are deleted. When the data is acquired in the uncontrolled environment, quality of the biometric data could be strongly depend on the surroundings. The future enhancement is we are going to work on with all the processors, not only with the Snapdragons. And these are some of the reference papers we are done with our project. Thank you for the very good opportunity. Our project is continuous user identity verification based secure internet service. This shows the home screen where the new user has to register the name and the email address and the password and their mobile number, which helps them to store their new account in the database, and so they can use this secured net banking, which makes their transaction more secure, and this creates their account. Once the registration is completed, they can log in with the help of their email and the password given during the registration, and this takes them to their net banking home screen. And this home screen consists of add new user, where the user has to store their photo, which is the image confirmation, and the update existing person is just changing the usage of the person, and this is to have the confirmation of the image, where the person can store their image and they can enter the person's name, which is shown at the background then and then on the home screen during the net banking service. The authentication is done at the background, which doesn't require the user authentication then and then, it's just been captured. And this is the user profile, which is viewed, the name, the username and the account number. Here the net banking transaction is done, where the send to consists of the account where the person is going to transact the amount, and the amount is being entered to proceed with the transaction, and the balance is now checked, which shows the current balance, and the back button takes them to the home screen, and the secured banking is done. Once the person's image is not recognized, the session is terminated. Thank you.